AlphaGo picks the best move out of more than 10 to the 170 possible games. That's more than the number of atoms in the universe. Question: how does a computer search a space that big and find the optimal play? The answer is one of the most beautiful ideas in all of mathematics. It's called dynamic programming, and it solves a class of problems called sequential decision-making. Things like, what's the shortest path through a city? What's the optimal sequence of moves in chess? What's the best way to manage a battery over a day? At each step, you pick an action, and your choice changes what comes next. The naive approach is to try every possible sequence of decisions, but the number of paths grows exponentially. 10 decisions, 2 options each, already over 1,000 paths. 40 decisions, a trillion. 200 decisions, more paths than atoms in the universe. The naive approach finishes after the heat death. Here's Richard Bellman's insight from 1953. He noticed something. The optimal path from A to B has a beautiful property. Every subpath is also optimal. If the best route through New York goes through Times Square, then from Times Square, you're already on an optimal route to your destination. Optimal solutions are made of optimal subsolutions. Out of that one observation falls Bellman's equation. The value of being in state S, V of S, equals the best action you could take, plus the value of where that action takes you. V of S equals max over A, a reward, plus gamma times V of the next state. A function defined in terms of itself. Here's how it works in practice. Imagine a grid. Goal in the corner, value 0. Now ask each neighboring square, what's my best move? Whatever is one step closer. So its value is 1. Their neighbors are value 2. And so on, rippling backward. You've now solved the entire maze for every starting position in one sweep. That's the wow. Exponential search becomes a polynomial sweep. Trillion path problems collapse to a manageable table of values. You never enumerate the paths. You reuse the answers from subproblems. This idea, in many forms, runs an enormous chunk of modern AI. AlphaGo uses it. Modern reinforcement learning is built on it. Every navigation app finds shortest paths with it. Compilers use it for optimal code generation. Bioinformatics aligns DNA with it. Inventory managers, schedulers, finance optimizers, robotics planners, all running variants of Bellman. Bellman's equation. One recursion. The impossible becomes routine. From AlphaGo to your phone's GPS, every shortest path was paid for by this one idea. If this broke your brain, hit like and subscribe. New engineering deep dives every week.